Okay, students, I'm going to show you two different ways of doing proof. This one came from a book. I'm going to go through these steps, explain these, and then I will show you how I would do it, which to me is easier than this. But the point being is that it's not just always one way to do a proof, so I want you to be able to see two different ways of doing the same thing. So again, the first thing you write down is givens. That never changes. Remember, we just watched the video on the general guidelines. Notice again, therefore, we have a vocab word as well here. Now, this red segment right here was not in the drawing originally. Okay, so we don't have a quote free piece. We do have HF. We have EF. Let me put that drawing. EF is congruent to EH. Okay, now you should have written down both of them up the first step, but here's an example again, like you can see on the DCAS, where notice the givens are split up. I told you sometimes they are. So this would be an example of this right here. So I want to go through and I want to find all my givens. I only see one of them right there. So I need to go find this given right here, which happens to be right here, and select from the drop-down menu on the DCAS given. That's what I'm talking about when they don't put them all in one step. And that's what makes it look like there's all these steps to this proof and it's a lot more overwhelming, etc. Okay, so we've identified the givens. And next, since we don't have a free piece, could have done the midpoint next, which they did. Step 2, HG is congruent to FG by definition of midpoint. Okay, remember, so here they write it out how I did, just definition of midpoint as opposed to writing out the definition itself. And then they've gone ahead and marked that on there. Okay. This particular person thought they need to go ahead and prove these two triangles congruent. And they knew they could go ahead and draw this segment in here, EG. So notice this draw EG. It's called auxiliary lines. Would be my justification for that if you're drawing in a segment that's not there. So auxiliary lines would be this, and then I can obviously say that segment is congruent to itself by reflexive property, which they did next. Okay, now I can go ahead and say those two triangles are congruent by SSS, which is what they did next. Okay, now don't forget, after I've proven true triangles congruent, then any of the other corresponding pieces, the other three, in this case are all three angles because we used the three sides already. So any of the three angles, corresponding angles, to be congruent by CPCTC. And they wanted this angle and this angle because our goal is to deal with angles 1 and 2. So they don't need to show that these up here are congruent or these right down here are congruent because those have nothing to do with angles 1 and 2. Oops. Okay, so that's why they don't identify those. They could have, and those would be the same justification as CPCTC, but there's no need for them. They just need these base angles here. Okay, so again, those two angles are congruent by CPCTC, always used after proven triangles congruent. Okay, well now I can say angle 1 is congruent to that angle, EHG, and angle 2 is congruent to that. Notice how they split them up. I would be putting, if I was to do this way, these would just be a semicolon, and this should just be written right up here, and I just have one, since it's the same justification, that's why you can do it. Linear pair theorem. Okay. So, number supplementary, two angles that add to 180. All right. And that's the definition of linear pair theorem. Adjacent angles that form a line. Two adjacent angles, not just adjacent angles, meaning 3, 4, 5, only two. So that justification is linear pair theorem. And now here's a new justification, and I've seen this on the DCAS that they'll use it. Supplements of congruent angles. So remember they already proved these two angles were congruent with the CP/CTC up here. Okay, and so supplements, remember they showed the word supplementary, that there's supplementary angles 1 and is supplementary to its linear pair, and angle 2 is supplementary to its angle linear pair. Supplements of congruent angles. Okay, so the congruent angles are these black angles right here that use CPC, and angles 1 and 2 are called the supplements of those. Supplements of congruent angles are congruent. Okay, and so now they have proven angle 1 is congruent to angle 2. Remember, your proof, whatever you're trying to prove, is the last step. Okay, so that's one way of doing a proof, and I want to bring this up because it had a couple new reasons or justifications that we haven't seen in other proofs, auxiliary lines if you're wanting to draw something there, and the supplements of congruent angles are congruent. I have seen that on the DCAS, so that's why I brought this proof in here. Okay, now let's do that same proof a different way. Okay, again, first thing I'm writing down are the givens, so I'm just going to draw that right there. One is given. Okay, I'm not even going to use this at all. Okay, so I can go ahead and do step 2, use my definition. Okay, right there. So I'm going to able to say HG, segment HG is congruent to FG by definition of midpoint. You know what? I don't even need that. I don't even need that. So I'm going to understand why the other person did what they did, because they're just as I was thinking, I'm going to always use that. I don't even need that. Okay, so I've got this triangle right here. We just showed or we're given that those two sides are congruent. So step 2, I'm going to say triangle HEF is isosceles, or isosceles triangle. Okay, definition of isosceles triangle. Okay, remember what's the definition of isosceles triangle? At least 2 congruent sides. Don't we have 2 congruent sides right there? At least 2 congruent sides. Yes, we do. Now, the reason we're having to say that, even though it's common sense that this is an isosceles triangle because we see 2 congruent sides, is because of my next step I'm going to use. Once I've identified it as an isosceles triangle, then I can go ahead and say base angles are congruent, those 2 angles right there. So I'm now able to say angle EHG, or I could have said EHF, is congruent to angle EFG by the isosceles triangle theorem. Remember, the isosceles triangle theorem says if you have an isosceles triangle, which is why I had to define it as an isosceles triangle, because now I can use that isosceles triangle theorem. Says if you have an isosceles triangle, then the base angles are congruent. Okay, so that's why I had to, in step 2, say it's an isosceles triangle, because it had that word in the isosceles triangle theorem, if the triangle is isosceles. So I had to define it as being isosceles first. That's why. Okay, so now I have those angles are congruent, and now I can finish off with what he had done in the previous. Okay, so now I'm going to be able to say angle 1 is supplement or supplementary to angle EHG. Angle 2 is supplement to angle EFG, and that's linear pair theorem. Right? They form a linear pair. Okay, linear pairs are supplementary. And lastly, now I can go ahead and use his final step as well, or hers. I don't know who the person is. Okay, and so notice our last step. See, I already was able to get all the way to this step. These two combine right there, linear pair theorem, and now our final step, supplements of congruent angles are congruent. So again, angle 1 is congruent to angle 2. Supplements of congruent angles are congruent. Okay, and see, so now I've cut it down to 5 steps. And so I put step 4 together. They've got it all separated out. They also split up the givens, and so it doesn't look nearly as intimidating doing it that way. But there's 2 different ways of doing the same proof. Okay, like I said, on the DCAS, they may go this route right here and have all these steps in here like this. Okay, again, on the DCAS, they would either give you a statement and have you choose a drop-down menu for the reason, or they give you the reason and have you choose a drop-down menu for the statement itself. Okay, so that goes ahead and explains 12 minutes.